Hi friends, this video brings out the understanding of the principle and types of fiber optics. Due to atmospheric conditions like rain, fog, the efficient communication is disturbed. Hence, to have an efficient communication system, the light which carries the information requires a guiding media known as optical fibers. Fiber optics is a branch of physics which deals with transmission and reception of light waves using optical fibers, which acts as guiding media. Let us see structure of optical fiber. This optical fiber is made up of plastic or glass. The core is made up of denser medium which is surrounded by cladding. Cladding is made up of rarer medium. Dia of the core is 50 micrometer and dia of the cladding is 200 micrometer. The cladding is enclosed by the strength members like Kevlar and polyurethane jacket. The principle of optical fibers. The principle of optical fiber communication is total internal reflection. For example, let us consider two mediums. Glass is denser medium, whereas air is rarer medium. When the light ray travels from glass, that is denser medium, to air medium, reflection takes place internally at a particular angle. The right hand side diagram, instead of air, I have chosen plastic, which is rarer medium. So when the light enters from glass medium to plastic, it reflects. This phenomenon is called as total internal reflection. So the reflection of the light ray just made to fall internally inside that medium. Next we are going to see about conditions for total internal reflection. The first condition, light should travel from denser medium to rarer medium. That means glass medium to air medium or glass medium to plastic medium. So symbolically we can write as N1 is greater than N2. N1 is refractive index of core, N2 is refractive index of cladding. The second condition is the angle of incidence should be greater than that of angle of critical. It's called the critical angle, can be notified by the symbol phi c. So phi I is incident angle, phi c is critical angle. Phi I is greater than phi c. This is the second condition for total internal reflection. Let us see what is critical angle later. Let the light ray transverse, that means travels or passes from denser medium to rarer medium. When the incident light is lesser than the critical angle, it is refracted to rarer medium. So the first result from this concept, when phi that means incident angle, which is lesser than the critical angle, the ray is refracted into the rarer medium. When the incident light ray is just equal to the critical angle, it just travels with an angle 90 degree. That means into the same phase, the phase between core and cladding. So from the concept, we come to the second point. When incident angle is equal to critical angle, the ray travels along the interface. The angle of refraction is 90 degree. This angle is critical angle, is denoted by phi c. When the light ray, that is incident light ray, is greater than that critical angle, total internal reflection takes place. So come to third point. When incident angle is greater than critical angle, the ray is totally reflected back. That is called total internal reflection, which is the basic principle of fiber optics communication. Now we are going to see about the features of optical fibers. It is light in weight. It is smaller in size and is flexible. It is non-conductive. It is non-radiative. It is non-inductive. Signals cannot be tapped. Classification of fiber optics. Fiber optics cable classified into three types based on materials, mode, and refractive index. Materials can be classified into two, that is plastic fiber and glass fiber. We will study about what is plastic fiber and glass fiber later. Mode can be classified into two. One is single mode fiber optics and multimode fiber optics. This single mode and multimode will be studied coming soon. Next, the refractive index can be classified into two, namely step index and graded index. Further, step index can be classified into two, single mode step index and multi-mode step index, where graded index we can have only multi-mode graded index fiber. The graded index fiber may be called as green fiber. That means graded index fiber. Based on materials in which the fibers are made, it is classified into two types, namely plastic fiber and glass fiber. Plastic fiber is nothing but if the fiber is made up of plastic, then such a fiber is called as plastic fiber. For example, polymethyl methacrylate. Next, glass fiber. If the fiber is made up of glass, then such a fiber is called as glass fiber. Example, silicon dioxide. Next, mode. Single mode fiber is nothing but it can allow only one mode of propagation. It is used in long communication systems. The diameter of the core is very small. The next mode of the fiber is multimode fiber. It can allow only many mode propagation. It is used in short communication systems. The dia of the core is larger. The total diameter of the single mode and the multimode fiber will be the same. Here the difference in diameters are compensated by increasing or decreasing the diameter of the two protective layers. Let us see what is refractive index profile. Based on the variation in the refractive index of the core and the cladding, the fibers are classified into two types, namely step index fiber and graded index fiber. The step index fiber, further it can be classified into two, that is single mode step index and multi-mode step index. Now we are going to see about the single mode step index fiber. The refractive indices of air, cladding, core varies step by step. It is called as step index fiber. So if the refractive indices of air, cladding and core varies step by step, and hence it is called as step index fiber. If the above phenomenon occurs in single mode fiber, then it is said to be single mode step index fiber. Next, multimode step index fiber. If the refractive indices of air, cladding and core varies step by step, and hence it is called as step index fiber. So more than one mode of propagation is called multimode. The refractive index of air, cladding, core varies step by step, and hence it is called as step index fiber. If the above phenomenon occurs in multimode fiber, then it is said to be multimode step index fiber. So the remaining one is, the last is graded index fiber. The last refractive index profile is graded index after the step index. In generally, multimode is only allowed, so multimode graded index fiber. Graded, that word is taken from the word gradual. So the refractive index of core is varied gradually or radially from the axis of the fiber. It is called graded index fiber. If the above phenomenon occurs only in multimode fiber, then it is said to be multimode graded index fiber. Fiber optics communication system. The propagation of information using fiber optics is fiber optics communication system. An optical fiber optics communication system consists of three major parts. One is transmitter, the second one is receiver, third one is optical fiber. In the transmitter, it consists two parts, namely drive circuit and light source. In the receiver, there are three parts. The first one is photodetector, second one is amplifier, third one is signal restorer for decoding purpose. Then we are already having the analog signal, electrical signal when we are using phone. So finally we obtained the block diagram of fiber optics communication system. Now we are going to how it is working. The information signal source may be audio or video. Signal is in the form of analog signal which to be transmitted through the optical fiber. The analog signal should be converted into electrical signal. The electrical signal further it is driven to drive circuit in the transmitter portion. The derived circuit transfers the electric input signal into digital pulses. The digital pulse is given to light source. The light source converts digital pulses into optical pulses. When the optical signal is entering the optical fiber, it just transmits the signal under the principle of total internal reflection. At the other end of the fiber optics, it is connected with a receiver. In the receiver itself, the transmitted optical signal is just entered the photodetector. In the photodetector, a photodiode is there. That photodiode converts the optical pulses into electrical pulses. Further, the electric pulses is amplified by the device amplifier. And further, the amplifying signal is given to signal restorer for decoding purpose. So converted the digital signal into electrical signal, then electrical signal is converted into analog signal. So in this way, the analog signal information is transmitted to from one end to another end. This is quick notes for fiber optics communication system. It consists three major parts. The first one is transmitter. The transmitter consists two major parts. One is derived circuit, another one is light source. In derived circuit, IC is there, which is used to convert electrical signal into digital signal. The light source, we are using LED, which converts digital signal into optical signal. The second major part is optical fiber. It transmits the optical signals toward the receiver by the principle of total internal reflection, and hence it can be acted as waveguide. The third part is receiver. In the receiver section, there are three major parts are there: photodetector, amplifier, and signal restorer. Photodetector. Avalanche photodiode can be used as photodetector, which is used to optical signal into electrical signal. Amplifier, which is used to amplify the electric signal. Then signal restorer, the electric signal to digital signal, further it is converted into analog signal. So in this way, the information is transmitted from one end to another end using optical fiber. Thank you.